So, hello everyone, myself Apurva Kaviskar, and today we will be going to learn about the chemistry. And in this chemistry topic, I have took elements, compounds, and mixtures. So, by the end of the lectures, we will be properly understanding the mixtures and the types of mixtures. So, before going on to the mixtures, let's understand the basic things. First of all, we'll look on to the definitions. First is element, second is compound, and the third is mixture. Element is something, a small unit. For example, this is my laptop on which I'm writing, right? So this laptop, for example, if this is my laptop, so element each and every same element will try to combine and form this whole PC or the laptop, right? So it is simply a smallest unit known as an atom. Example of atoms are metals, non-metals, and metalloids. We will be going to learn about metals, non-metals, and metalloids. But for this, just understand what are the examples and what are the definitions, how to understand the element, compound, and mixture. Next thing, what is compound? See, element is something a smallest unit. Okay. Now let's go further. After continuation of elements, when the two element, for example, same element, okay, same element or two another elements, for example these are my a and a, if this is my a and b, when they combine or they come together, then they form what? They form a compound. They form what? They form compound. See, formed by combination of two or more elements, so organic and inorganic compounds. Next, after the compounds, now after continuation of this compound, when two compounds combine, we get what? Mixture. We get what is a mixture. So mixture is, for example, sugar is one compound, water is another compound. So when they will combine, you will get a sugar syrup. That is a mixture. So what we understood, that this is my element combines to form a compound, and two compounds of different forms will combine to form a mixture. This is my mixture, this is my compound, and this is my element. So which is, if dash is the smallest unit, so element is the smallest unit. Okay. Next, now we'll understand the examples of metals elements. That is a metal. Now metal is something which is solid. Okay, see, this is the solid, this is solid, this is also the solid. So metals are generally solids. What are the characteristics? Because they are solid, so they will have a hardness. Now malleability and ductility, what are those terms? See, malleable is something where we can, if this is my metal, I can make this metal in the form of wire like this. These are my wires, metal wires. So I can malleable. The term malleable is something where we can hammer it and make it in a thin form that is mean to be as a malleability. Okay. Now we'll understand the term ductile. Now why the metals are ductile? Okay. See, metals malleable means what? Anyhow we can hammer it and make into a thin wire. Now ductility means what? It is this term where the metal or the solid can be deformed, means we can convert into any other shape. Okay, that is called ductility. So the ability of this ductility, it will help the solid to get into another shape without breaking. High tensile strength. See, it cannot break, so it will be having obviously high tensile strength. It is lustrous, shiny, and ability to conduct it and electricity. Most of us would have seen the electricity में ये वाले wires use करते हैं, इसको तार बोलते हैं. We use these metal wires in the electricity form. So metal is generally which we have. Now totally opposite to metal is a non-metal. This one. See, these are generally non-metals. Brittle, the opposite, where they were shiny, these are brittle. They were good conductors of heat and electricity, they were bad conductors. Example is what? Oxygen. Okay. Example is oxygen. Next, metalloids. Now metalloid is something which has got a property of metal also, as well as non-metals also. Okay, means they will exhibit both. If they will exhibit good conductors also and exhibit bad conductors of electricity also. So these elements have characteristics common to metal as well as non-metals. So some examples are this: boron, silicon, germanium. Are you able to see this? This is something called chip, mostly in mobile, laptops, even laptops we use this chips, and this chip is made up of what? Metalloid. Okay, arsenic, bismuth and antimony. Now going further, compounds. What is compound? See, compounds are, we know that two elements combine to form a compound. So compounds are of two types. First is organic compound and another one is inorganic compound. Organic compound, every time you have to remember, we ourselves, humans, are made up of carbon, hydrogen, right? See, carbon bond is present in us. See, this is the carbon, 6 is the atomic number of carbon. And organic, all the organic compounds are made up of carbon only. See, the main content is carbon. So everything made up of carbon and hydrogen bondings are falls into the organic compound, originally obtained from living sources, that is animals and plants. Some examples are oil is again CH, fats CH, as well as there are fatty acids and all. Again protein has CH bond along with amino acids. So all the compounds which has a carbon and hydrogen bondings are comes in organic chemistry. And apart from CH bondings, all comes in inorganic. See, these compounds find their origin from the non-living sources such as minerals, common salt. Now common salt is what? NaCl. NaCl doesn't have carbon, right? So this is in marble, calcium is present in marble, so calcium is not made up of carbon. Okay, so this is all. Apart from carbon hydrogen bondings, all are inorganic compounds. Fine. Next, let's understand the definition of mixture. We'll understand the different types of mixture, that is homogeneous and heterogeneous mixture, and we'll compare and contrast solutions like colloids and solutions. Fine. Let's see what is a mixture. I said it is a composed of two or more substances that are combined yet can still be prepared. So we'll understand. See, there are two types. Fine. Has a uniform compositions all throughout and has a varying composition. The one who is having uniform compositions are called homogeneous mixture. What they are called? Homogeneous mixture. Because uniform composition means, if we cannot, for example this lemonade, okay, nimbu pani, we cannot further extract nimbu from this pani, so it is a uniform composition, we cannot further filtrate, cannot be filtrate further. So this is a homogeneous mixture. As well as you can take out this chicken, corn from this whole food. So this is a heterogeneous mixture. Heterogeneous mixture. Understood? So what is a mixture? Mixture is a homogeneous and the heterogeneous. Homogeneous is something having a uniform composition. Heterogeneous is something having different compositions which can be filtered out. This cannot be filtered, this can be filtered. What are the difference between the mixture below? See, this is my alcohol, milk and muddy water. Alcohol is something which we cannot filter, right? Even milk we cannot filter, but milk and rubbing alcohol has got some different constituent, means particles inside this and particles inside this has got a different size, which we are going to learn. And muddy water is obviously we can filter it, means not totally we can filter, the stones can be filtered. Now see, some particles are visible and some are not. Yes, na? In this we cannot see that much particles, but in muddy waters we can see the stones and all the mud particles. So what are the types of mixtures according to the particle size? Now we are going to differentiate as per the particle size. See, solution is a homogeneous mixture. Particle size 0 to 0.001 to 1 nanometer. Just a minute. Now see here, heterogeneous, and this is also heterogeneous. We'll do comparative studies. This is my solution, this is my colloid, and this is called something called suspension. See, here only this solution is homogeneous. Why solution is homogeneous? See, once we make a tea, we cannot filter the tea, right? This is what we call, for example, salt and water. We cannot filter salt and water physically, but there is one more condition, that we can filter it using some extra conditions we have to apply, but physically we cannot. So it is a homogeneous. Colloid and suspensions are little bit same, only there is a difference in particle size. This is 1000 and here is 1 to 1000 nanometer. Okay, this is only direct over 1000, and this is 1 to 1000, means it comes between 1 to 1000 nanometer size, and this 1000. Particles do not separate. Particles are large enough to settle, can be separated by filtration, do not separate, cannot be separated by filtration. Here it can be separated, obviously. See, this is my pickle. I can take out mango pieces from this pickle, right? So it can be separated. So mango pickles are suspended in this oil, so this is my suspension. See, milk is something, we have heterogeneous mixture because there are particles present, but these particles are not visible to the eyes normally. So these are 1 to 1000 nanometer. Okay, suspension. So if I review, mixtures, two or more substance combined yet can still be separated into the original parts, that is homogeneous and heterogeneous. And these are the conclusions, like solution, colloid, suspension. Particle size you have to remember, this may come in the form of MCQ. So this is some identifying